Welcome to COSC 1436. This is chapter 3 that we're going to be covering. I'm going to share my desktop and I'm just going to run the PowerPoint side by side with my editor, my coding editor. Okay, so that I can show you some of these things, type them up so you can see how they run and how they work. I think that would work a lot better. Okay, so chapter 3 covers expressions and interactivity. So the first thing we're going to look at is the CEN object. So we have used the C out object, and the C stands for console. So the console means that the output is going to be coming, you're going to be seeing it displayed on the screen, and the input is also going to come, the input's going to come from either we can get the input from a file, or we can get the input from, right now, we can get the input from the keyboard. So we're just going to be studying right now how to get the input from the keyboard. The cout required us to use a library called input output stream. So this is a file that we did pound include. CN also uses the same file. And the difference here is going to be when we retrieve the information, we're going to use the greater than signs. With the cout, we use the less than signs. So here's an example. In this program, it says, this program calculates the area of a rectangle. These are output statements that will show on the screen. And then it asks the question, what is the length of the rectangle? So whenever we do a CN statement, let me just do one here. So we're going to include IO stream. And using namespace. Int main. Open curly brace, close curly brace. Remember, main and int have to be lowercase. Int is blue because it is a reserved word. And so let's say that I wanted to ask, how old are you? How old are you? Question mark. And so age is going to be, people are between the ages of 1 and, I don't know, let's say 120. And so that's going to be an integer. So I'm going to go ahead and define an integer here called age. And I'm going to initialize it to 0. And then I'm going to CN. So we have CN greater than sign. So I can make this bigger so you can see it better. So CN greater than sign, and then my variable called age. Whenever you get input from the keyboard, always ask the question. So we're not just going to assume that the person knows what they want to enter. We want to tell them what they want to enter. Also, if you want them to enter something, all capitals or in a certain format, then you have to tell them that. Just like sometimes when you fill out things on the computer, like on the internet, it will give you an exact way to enter a birth date or a phone number. It has a special format. So this just asked, and then I want to say cout, your age is age. Okay. And then we're going to run it. So when I run it, here at the bottom, it has this blinking cursor. The blinking cursor is caused by that CN statement. It allows me to input from the keyboard. So Say I'm 18 years old. Press enter, your age is 18. So it outputs. But you got to ask what it is that you want them to enter. Don't just have a blinking cursor without like the user knowing what they need to enter. CIN converts data to the type that matches the variable. So here what it's saying is, let's run this again. And this time when it asks me, how old are you? I'm going to enter the capital A. So capital A is, you and I know it's a character, but we're assigning it to an integer. We said that age, the variable age that holds that value is an integer. So it doesn't understand what the variable A is. And so it converts that to an integer and just puts a 0 on there. Let's see if we don't assign. We don't assign this. Let's see what it does. Still makes it 0. So let's run it again. And this time we're going to enter, oh, I am 18.5 years old. So if you put 18.5, this is a floating point number, has a decimal, and it drops or it truncates that 0.5 and it just stores the 18 because age is an integer. Okay. So this is a prompt, is all that is saying here. Is just you should always use cout to display a prompt before each CIN statement. You can use, you can input more than one value with one CIN statement. So for example, here I can say, how old are you? And what year, what month? So I'll say, what month is your birthday? Ah, how did I get up there? Birthday. Question mark. All right. So here I can say CIN, although I would say do not do this. This is not very pretty. Month. I have to define month. Your age is age. Cout. I don't like this, but I'll show it to you anyway. Your birthday month is month semicolon. Okay. So now I'm going to run it. How old are you and what month is your birthday? So 18 and the month, let's say it's 7. So it says your age is 18, your birthday month is 7. It gets it both. But you don't want to do this. You don't want to have the user have to enter a space. The best way to do this is to break the questions out into 2 things. So we want to ask first, how old are you? CIN age, and then what is your birthday month? CIN month. CIN objects read different data types. So what this is saying here is that if you have an integer, whole, double, fractional, char letter, you can CIN an integer, a fractional number, and a letter. So it's just saying that if you define, let's say, a character letter, and you ask the user cout, enter a letter, enter letter, CN letter. So CN can be used with strings, it can be used with characters, floating point numbers, integer. You can input anything from the keyboard. That's all that is saying. C out letter is letter. Oops. Notice CN greater than sign, C out less than sign is going to the left. This is going to the right. The way I think about it is with the CN, the value that I enter into the keyboard is going into the variable. So you can remember it's going to the into. It's pointing to the variable. So it's going into the variable. And I think that's it. I wanted to show you on there. So let me run it one more time. 18:7, letter A. And it says your age is 18, your birth month is 7, letter is A. So here I forgot to put my end line, and so it joined those two C out statements. So that means I need an end line right here. Or I could put the end line in here if I wanted to. Like I could do this. But typically we just put it at the end. It's just it looks better. It makes more sense. It's kind of like pressing the enter key. Remember, end line is end L for line, not the number 1. And your age is 18, birth month is 7, letter is A. Okay, mathematical expressions. Very important. When we do mathematical expressions, there is an order of operation. There is a way to multiply and calculate things. So in this example, this has the order of operation. So actually it doesn't show parentheses. Okay, so the order of operation here, first it has the negation. Negation means that like a negative number. If you say -2, that's going to happen first in order from left to right. Multiplication, division, and modulus will happen next in order from left to right. And addition and subtraction happens next in order from left to right. Okay, so this is really important. Let's go up here. I'm going to just take all this out, and I'm going to create an integer called number 1. And that equals 5. And an integer called number 2, and that equals 10. And an integer num 3 equals 2. Okay. So if I see out num 2 divided by num 1 times num 3. Let's just say that. Okay, whoops, num 3. So what's going to happen here first, see, division and multiplication have the same priority. And so whatever comes first, if multiplication comes first, we do that first. If division comes first, we do that first. So here, division is going to come first. So that's what's going to happen first. Num 2 divided by num 1. Num 2 is 10. Num 1 is 5. That gives us 2. 10 divided by 5 is 2. 2 times 2, which is num 3, would give us 4. See how, if I did my calculation correctly, oh, this is just see, I didn't assign it to anything. So I just see outs to the screen. So the calculation is 4, shows 4 down here. Okay, if I change this and I say num 3 times num2 divided by num1, then now something different is going to happen. Right now, what's going to happen is this num3 is going to get multiplied. This will happen first. So 2 times 10 is 20. 20 divided by 5 is 4, which was the same answer as before. But this will happen first. It just happened that I did something very similar. 20 divided by 5. Yeah, it's 4. Okay. So this will happen first. The multiplication will happen first. And if I have addition and subtraction, notice addition and subtraction happen after multiplication and division. So let's say that I add here, I say 1 plus, then all this will happen first, and then the 1 gets added because the 1 doesn't have priority. The plus doesn't have a priority over the multiplication, division, and modulus, okay? It comes after. So let's run that. It should be 5. There's a 5. So it does all this first. That gives us a 4. 4 plus 1 equals 5. Parentheses can change the order if you want the order to be different. So if you want this to happen first, so if you want to say 1 plus num3 is 3. 3 times 10 is 30. 30 divided by 5 is 6. And so you can change the order, and there's the 6 right there. Okay, so for your quizzes and for your test, you really have to know your order of operation. It's the same as you took in regular math class. But if you don't remember it, you need to make sure you study it, you do practices so that you know how to solve some of these problems. The other thing that we have is the negative sign, and the negative sign, all that does is it turns, so like if I have a negative sign here, I'm going to put parentheses around all this stuff. Okay, so remember that gave me a 6. So now if I put a negative sign there, it's going to do all these things inside, and then it's going to make it a negative number. Okay. So -6. Now, if I want the negative to get added to something first, then let's say that, let's say -1. Take all these parentheses out. So here, what's going to happen first is num3 gets multiplied by num2. So num3 by num2, that's a 20. 20 divided by 5 is 4. And so you're going to have a -1 plus 4. -1 plus 4 would be 3, because you're just taking 1 away from the 4. -1 plus 4 is 3. I'm spending a lot of time on this because this is really important that you understand 3, how these work, because these are going to be a big part of your grade on your tests and quizzes. So these are just some examples. Here we're going to do 2 times 4 first. That's 8. 8 plus 5 is 13. Here we're going to divide first because division has priority over subtraction, and it just happens to come first. 10 divided by 2 is 5. 5 minus 3 is 2. Here, even though 8 plus is here first, we're not going to do this first. We're going to multiply first. We're going to go to the middle. 24. This is 24. Now we start from the 8 because the plus and the minus have the same priority. So 8 plus 24 is 28. 32. 32 minus 4 is 28. Here, again, modulus has priority over the plus and the minus. Modulus gives you the remainder of these two numbers divided. So 12 divided by 2 is 8 with a remainder of 1. So this here is 1. 4 plus 1 is 5. 5 minus 1 is 4. Here we're going to multiply first before we subtract, add, and then subtract. 3 times 2 is 6. 6 minus 6 is 0. 0 plus 7 is 7. And 7 minus 1 is 6. Excuse me. Here they're just showing you parentheses like we went over earlier. Priorities. Parentheses can override the order of operation. So if you want to override it, just use the parentheses. So here's some examples where they override the order of operation. Here the addition will happen first, and then we'll multiply it times 4. So 5 plus 2 is 7. 7 times 4 is 28. 5 minus 3 is 2. 10 divided by 2 is 5. 6 minus 2 is 4. Then we multiply 12 times 4. So 12 times 4, 4 times 48. And then 8 plus 48 is 56. 4 plus 17 is 21. 21 modulus 2. So 21 divided by 2 is 10 with remainder 1. Because 20 divided by 2 is 10. So 1 minus 1 is 0. So again, this modulus gives you the remainder of the two numbers after you divide them. 6 minus 3 is 3. 2 plus 7 is 9. 6 minus 3 is 3. 3 times 9 is 27. 27 divided by 3 is 9. So that's how that works. Order of operation, make sure you understand it really well. Practice a lot with that. Multiplication requires an operator. So in algebra, we can just say variable, we can put a variable next to another variable, and we know that that means multiplication. But in programming, we can't do that because this LW would be one variable. But L we know is one variable and W is a different variable. So we got to have the star for multiplication in between those. If you want to raise a variable to a certain power, like s squared, you have to use this function called pow function, which is the power function. So s is going to be raised to the power of 2. You can put a 3 here, or 4, raised to the power of 5, whatever you want. Then here it shows you how you may need parentheses to maintain order so you can write an equation like this one. So in this equation, which is the slope equation, you have, you want to do this first. So you have parentheses, get that done first, then do this, then divide this number by whatever this number is. Okay, so this is some examples with, this is the algebraic equation, and this is how you have to write it in C++. 6 times b would require an asterisk. 3 next to 12 in parentheses, an algebraic expression would require an asterisk. And then 4 times x times y would require 2 asterisks in between those. When you mix apples with oranges, type conversion. So what this is saying is, like, what if I take an integer and I assign it to a floating point variable? So my integer is my apple, my floating point variable is my oranges. So I'm assigning it. And so what happens, so if I assign an integer to a floating point number, my integer gets converted to a floating point number. If I assign a floating point number to an integer, my floating point number gets converted to an integer. When you mix apples with oranges, operations are performed between operands of the same type. If not of the same type, C++ is going to convert one to be the type of the other, just like we talked about. This can impact the result of calculation. So if you do this on purpose, that's fine. But if for some reason this happens and you don't know that it happened, then you're going to get calculations that you were not expecting. So this is the hierarchy of the types. We have a long double, a double, a float, unsigned long, long, unsigned integer, integer. So this is the smallest amount. This is the smallest number. An integer can hold the smallest number. And actually there's a short integer, but we don't use that one. Then you have unsigned integers, a little bit longer, long, unsigned long, float, double, so on and so forth. So it's ranked by the largest number they can hold. This is the largest number that they can hold. Type coercion is automatic conversion of an operand to another data type. So that's what we were talking about. Assign integer to floating point number, automatically that integer gets converted to a floating point number. That's called a promotion. The integer got converted to something bigger. A demotion would be the floating point number getting assigned to an integer, gets that floating, all the numbers of the decimal get truncated, not rounded, truncated. And so that's called a demotion. So we're going to go to a lower data type, floating to integer. Coercion rules. A character is short, an unsigned short automatically get promoted to an integer. When operating on values of different data types, the lower one is promoted to the type of the higher one. When using the equal operator, the type of expression on the right will be converted to the type of variable on the left. So here, this is what we're talking about here. If we have float num1. So if I say float num1 equals num2, so float num1 is a float, num2 is an integer. Let's see what happens. So we get a 10. Now this 10 here, oh, and I get some warnings. And let's do it the other way. So let's say this equals, and that would be a 10.0. Let's say that this is 9.897. And this time num2 equals float num1. 2. Run it. I get a 9. So everything after the 9, the 897 just got truncated. And sometimes you might want to do that. You might want to truncate a number because you're needing to, that's part of what your calculation or however it is that you're doing something, and that's how you can truncate the number if you're not needing the decimal piece. Okay, so overflow and underflow. Overflow and underflow occurs when assigning a value that is too large or too small to be held in a variable. So for example, so it says variable contains value that is wrapped around set of possible values. Different system may display a warning or an error. This is what happened here earlier. Well, here we have an error also. Is telling us, not an error, but a warning. So it's giving us a warning. Earlier, it gave us a warning too when we tried to do it the other way. And some programs won't let you do it. Some applications won't let you do it at all. And we saw that earlier too. We assigned, I think it was a character, the letter A, to an integer. It just gave us a 0. Typecasting, this is where when you're like, yes, this is what I want to do. So let me do it. So for example, if I'm going to divide num1 and num2, and let's say that I make this a 13, and I say, no, I'm gonna assign it to this floating point. Okay, so I'm just gonna make it 0. And I'm gonna say float num1 equals num2 divided by num1. I need this, I'm not using it. And I'm gonna output float num1. Okay, so I'm dividing 13 by 5. Since the wrong way. By 13. Okay, since it's going to give me a decimal number, but if you remember from the last chapter, an integer divided by an integer is going to give us assigned to this, it's just going to give us an integer. So when you have two integers, the value here is going to be an integer. So if I want this to be changed, so let's just run it so you can see that first. But if I say, okay, I want it to be a floating point number, why does it say 0? Why my brain's not working? Okay, so I got a 2. So 13 divided by 5, we know is 2 point something, right? And one way that I showed you was these numbers, we had made them like 5.0 or something, but we can't do that here. So one thing that we can do is we can put the word float here in parentheses, run it, and that did not work. Should work. Let's try using a different method. So the preferred method is static cast float, and then parentheses around what we want to make a float. Hopefully that will work. Still gives me a 2. Okay, let me just put a number here. Let me put, we're doing division. Let's do num2. Let's make num2 see if that works. That gives us, well, still changes it. Gives me a warning because it's changing it to 13 here. Okay, so in theory, this would have given me static cast float. I don't know. I'm not sure why it's not working. it would show a floating point number. So here we have double M equals static cast double. So whatever this comes out, it's going to change it to a double and assign it to M. Here you have a character that's the letter C. And then here it shows you what C is as an integer. So I guess we could try that one and see if that one works. Character CH equals C. And then here we're going to put CH. And we're going to assign it to an integer. So we'll assign it to num1. Don't need num2. Don't need zeros. And one's just going to be 0. And here we're going to show num1. So num1 is 0. Character is the letter C. Or CH is the letter C. Num1 equals static cast int CH. So we convert it to an integer. Oh, wait. It float. Okay, and then we see out num1. All right, crossing my fingers. Yes. Okay, so this gives us a 67. So in ASCII, capital A is a 65, capital B 66 is an integer, and capital C 67. And I think I mentioned this last time. You want to know the ASCII values because you're comparing capital, like if you're comparing a name and you say, is Aaron greater than Carlos? Well, Aaron starts with an A, which is a 65. Carlos starts with a C, which is a 67. So Aaron would not be greater than Carlos. It would be less than. Okay, so it comes first in the alphabet. A is less than C in the alphabet. Here's some examples, some other examples. This is another way to typecast, and it's just, this is the C style in C programming. We would put int in a parentheses and then the variable next to it. C++, you would just put int and then in parentheses, you would put the variable, which is what I tried to do earlier, but it didn't work. But, so these are still supported in C++, but this here is the preferred method of doing it. Multiple assignment and combined statements. So here's just showing that we can do x equals y equals z equals 5. And then what it does is it starts processing from here. So 5 gets assigned to z. Z is now 5. 5 gets assigned to y. Y is now 5. The y gets assigned to x, which has a 5. So x equals 5. So now all 3 variables equal a 5. Sum equals sum plus 1. This is how we create this is how we make an accumulator. So when we're trying to accumulate values, and we'll do this when we learn about loops, you use the same variable that you're assigning to in your equation. So sum equals sum plus 1. So let's say that sum is 10. 10 equals 10 plus 1, so sum gets changed to 11. So you're increasing by 1. Here's some other similar statements, make them a little bit bigger. X equals x plus 4, you're adding 4 to x. So if x is 5, let's say, well, no, it says here x is 6. So 6 plus 4 is 10. X gets changed to 10. So you've got x is 6. Now you're adding 4 to it. Now you're subtracting 3 from it. Now you're multiplying 10. So here, if I make num 10 and I say num1 equals num1 plus 1, then my 10 is going to go up to 11. And there's the 11 right there. Okay. Then there's a combined assignment statement. So this is also important. Make sure that you understand how this works. Let's delete that. We're not using it, so we don't get that warning. Okay, so this is the same thing. Put it in here. I put 2 forward slashes. That's my comments. So it's not going to get compiled, processed. Num plus equals 1. This is a shortcut for doing this. Okay, this is a shortcut. This came when C++ language was created. So before, when it was just C programming, this is how we incremented our values. But when C++ was created, then we were able to do this. So we combine the plus and the equal sign, and it just increments your number by 1. Or if you want to increment it by 10, put a 10 right there. So now it would be num1 would be 20. I'll put a 1 right there and run it. Num1 is 20 because num1 started at 10. 10 plus 10 is 20. The equal sign assigns it back to num1. It overrides the 10, and now it has a 20 inside the variable. We can do the plus, we cannot combine any operators. So look here, combined assignment operators. So we can do minus equals 10. So this will take the 10, subtract 10 from it, and assign it back to num1, and it's going to give us a 0. So there's a 0. You can do multiplication. So, oh, that's not multiplication. What's happening? Where am I? There we go. So here we'll multiply num1 times, so num1 is 10. So 10 times 10 is 100. The 100 gets assigned to num1. And there's our 100. So you can combine all the different operators here. There's also another one that it's not showing it here, but I'll show it later. And it's if you do this num1 plus plus, this just increments it by 1. So it's going to go up to 11. And it just increments it by 1. Plus plus is just incrementing by 1. And then num1 minus minus run decreases by 1. So that's another little shortcut if you just want to increment by 1. Formatting your output, there is a header file called output manipulator, iomanip. Iomanip is input output manipulator. What this does is it gives you access to how you control your output. So it says formatting output can control how output displays for numeric string data. So the size, the position, the number of digits that you see. Let's look at some examples. First of all, the function's called setW, set width, the width. Here's one. X. So let's say that you have the number 10 and you want to set the width of where that 10 is shown to be like 50 spaces or 5 spaces. Then that's all that's going to give you for that 10. And it's nice because then you can align. If you have a lot of stuff to display, you can align it. So here's an example. We have all these numbers here. And it sets the width of displaying these numbers to 6. So this has 6 spaces. So you're going to have 2 spaces blank, and then it displays the 4 numbers. Num2, same thing, set width to 6. So you're going to have 5 spaces blank, then the 5. And let's see if it shows us the output. Yeah, on the next page. So the nice thing about it is that it aligns. You can write justify and make an output look nice with set width. So set everything to 6 so that all the numbers would be aligned. The other thing that we can do is set precision. So set precision is when you have a floating point number. How many digits do you want to see after the floating point number? Do you want to see just 1? Do you want to see 2 digits after the floating point number, 3, etc.? So show point, always print the decimal for floating point values. So it just prints the decimals. That's all that does. So let's look at some examples with those. So here we're entering the sales amount for day 1, day 2, day 3. We're getting the sales amount and we're just adding them together and making a total. So the user enters those, and this gets a total of the 3 days sales. So let's say that they entered 1,321.87, 1,869.26. These are the 3 days of sales. So this is the 3 days of sales. When it's going to output, the day, the word day 1, colon, space. It's going to have 8 spaces to show the day's worth of sales. 1, 2, 3, 4, 5, 6, 7, 8. So there's going to be a space before the 1, and then it's going to show the number. And that's it for that one. Oh, we have set precision 2, so it's going to show 2 numbers after the decimal. So set precision 2 means always show me 2 numbers after the decimal. Oops. Let's see. Oh, here it is, right here. And then earlier this talked about fixed. So fixed means use decimal notation for floating point values. So it just means that it's always going to use the decimal notation, even if it's like a scientific notation type number. Show point again always prints decimal for floating point numbers. So for this, let's see if I have 1,000.9999. And then, so looking at this, I have to add IO manip up here, input output manipulator, this file. And why do I need that? Well, I need that because inside this file is where set precision function is defined and set width function is defined, and this file knows what this word fixed means. So I have there. So before I go ahead and output, I should change this to a float. And I'm going to see out, set precision to, and I'm not gonna set a width. I'm just gonna say set precision to, okay? Let's see. By the way, I don't have to do a separate see out statement. I can just do it here. The only thing is if I do it there, then it's only gonna set precision to for this num1. So let's run it. Let's see what that does. Oh, so this one, because it's a float, oh, I didn't say fixed. So that's why I didn't do that. All right, so let's go ahead and add fixed right there because we just want decimals. We don't want to see this notation, this scientific notation. Okay, so we have 1001.00. The number that I had was 1000.9999. Because I did set precision to, it rounded up. And so since it rounded up, then it rounded up to 1001. But let's say that I just say 2. So I have 100.22. It's going to start rounding up if it's 5 or above, if the number is 5 or above. So right here, if I say 5. So it becomes 26. My 25 becomes a 26. So I can put set precision to here, or I can put in a separate line like this. Let's say that I have a different number. So let's do float num2 equals 300.333. And I'm going to just output inline num2. Okay. And run. Num1, num2. There we go. So num2 is 300.33. So 2 numbers after decimal. So by putting it here in the C out, it does set precision to everything after. I thought it only set precision to num1, but I'm wrong. It's set precision and fixed to everything after that. So any C out statement from then on, it's going to go ahead and just do this. Okay. So these are just the different string manipulators options that you have. These are functions. If you have a parentheses, then if you have a parentheses after a word, that's called a function. Show point causes a decimal point and trailing zeros to be displayed even if there is no fractional part. So it would show like 10.00 if you do show point. And then left and right causes subsequent output to be left justified or right justified. So if we want everything right justified, then we want to use right. We want it to all be lined up. Like if you have 1,300. So for example, like, let's just run this real quick. And okay, so this is what we call left justified. So the 1,000 and the 300 are lined up. But if you want the decimals to line up, then you want it to be right justified. So we'll put right. not right justify it for me. Set precision, fixed, right. See if it does both of them. Nope. Okay, I'll have to look at that and see why that didn't work. Working with characters and string objects. Check this a little bit smaller. Let's see. There we go. So using CN with the greater than operator to input strings can cause problems. It passes over and ignores any leading white space characters, spaces, tabs, or line breaks. So what that's saying is this: if I create a string variable here and I say CN Jeanette space Serrano, it only gets Jeanette. If I use CN, it does not get Serrano. So I have to use a function called getLine if I want to get something that has spaces. Let's look at an example here. We have string name, string city. Please enter your name, getLine name. So here you can enter the full name, Jeanette Serrano. And here you can enter a city that may have 2 words with spaces. So first of all, we're going to use a string. So I'm going to go ahead and add the include file to be able to use strings. I'm going to define a string called name, and I'm going to say enter your name, CN name, cout. Your name is name. Okay. So first I'm going to use CN, which is what I don't want to use if I'm getting a name. If I'm getting anything that may have spaces, I don't want to use CN. I'm going to enter Jeanette Serrano-Correa. And oops, press enter. And it says your name is Jeanette. So CN only gets information until the space. So what it's preferred to do is to use getLine. So here I do getLine CN comma name and then run it. Jeanette. And then my whole name shows, because what it does is getLine, what that function does is it gets the input until the new line, until you press enter. So it gets whatever you type until you press enter. So if I do blah 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 space blah 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 space blah 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 space, it will get everything that I typed. Everything is there until I press enter. That's getLine. Okay. To read a single character, you just use CN, and then you can get the character. Or you can use cn.get. This will read the next character entered, even white spaces. Here's an example. This program has paused. Please enter to continue cn.get.ch. So this is going to get the enter key. When you press enter, this will get the enter key. It has paused a second time. Please press enter again. Oh, this is another way to do it. So you can do cn.get.ch, or you can do cn.get without doing ch, just assigning it. So here it assigns it here inside the parentheses. Here it assigns it with the assignment statement. It has passed the third time. Just do see and dot get without any assignment. It gets it and it does nothing with it. Like here, you're just not saving that new line. You don't need it, so why save it? Mixing cin and cin.get in the same program can cause errors. This is also really important. May happen to you. So if I'm trying to think, I get my name into, all right, let me just do it here. And then, so if I say cout, enter your age. Okay, so this is an integer. Sin age. Let's go ahead and define my variable integer age so that I can use it here. And then I'm going to cout your age is age. All right. Okay, enter your name. I forgot my space. That's okay. Okay, your name is Serrano-Correa. Your age is 18. Oof, that's really ugly. Let's fix that real quick. So here I'm going to put an inline. No, what was the problem? Oh, the problem was here. I need a space there. And then I need an end line right here. Okay, let's make that nicer and run it. Name. Your name is, your age is. Beautiful. Okay, now let's swap this. Let's ask for the age first. And then ask for the name.